Hello, so continuing on this weekly contest 163, the second problem is find elements in a contaminated binary tree. The problem says we have a binary tree with 3 rows. The first rule is that the root value is 0. The second rule is that if the root has a value, or a tree node has a value and it has a left node, then that left node's value should be 2 multiplied by x plus 1. If a node also has a value and has a right child, then that right child value should be 2 multiplied by x, where x is the value of the parent node, plus 2. So these are the properties that we want the tree to have, that a non-contaminated binary tree has. And then, however, in the input, the binary tree that we get is contaminated, where all the values are transformed to -1, right? So the goal here is to recover the tree, and what really Leetcode checks is this find target. It will give you a value and checks if it will be found in the recovered tree. If we were to reconstruct the recovered tree, would we have that target value? So this here is pretty straightforward. So if you look at -1, -1, 0, the right child, since it has only right child, the right child is 2 multiplied by 0 plus 2, so that's 2. It doesn't have a left child, so there is no left child value. Here you can see the root is 0, left child is 2 multiplied by 0 plus 1, so it's 1. Left child of 1 is 2 multiplied by 1 plus 1, so it's 3. Right child of 1, 2 multiplied by 2 plus 1. You get the idea. 2 multiplied by 1 plus 1, it's plus 2 actually, so it's 4. But you get the idea. So once you get this tree here, searching for value 1, it will be found, so we return true. Searching for 3, we'll find it. Searching for 5, we won't find it. So what this means is that so in the constraint, the head of the binary tree is less than 20. The total number of nodes is 10 to the power of 4, and the number of find calls is 10 to the power of 4. So this is the important point here, which is that find will be called the lat. So find needs to be really optimal, maybe O of 1, but the initialization step, since it's called once, it can be a little bit more expensive. So that tells us that we need to recover the tree, or the tree values at least, in the initialization, so that find is quick. So how can we make find quick? If we were to search like in a set, like just check if a value in a set then is in a set, then find would be O of 1. And so that's exactly what we'll be shooting for. And to do that, we can just, while recovering the tree, just put the values that you find in a set, so that searching for target would be just searching in that set instead of searching on the entire binary tree, because searching in the set is O of 1, searching in the binary tree log of n, right? So let's do this. So the first step is to initialization to get the set. So so essentially what this means here is that, well, we can just define a function recover. I can of course define this method outside of the init, but just doesn't matter really, we can put it here. So we can just do a DFS way, where we call recover on the entire tree, right? And then here, if we are we are done, like we passed the leaf and this is none, then we return, right? There is nothing to do anymore. But remember, we said we need a set, so that find is really easy to do. So we define a set of values here, right? And since the first node of the tree, as the problem says, is 0, has value 0, so self.root.val. So actually not self.root, but root.val is 0, right? And here, because we will be populating all the values in self.values, we can do an O of 1 search, where we just say we return if target is in sub-dot values, right? And now what should recover do? So recover needs to check if this, just the problem statement which says that if there is a left value, then sorry, then its left node value is the value of the node, which is the parent here, which is node.val plus 1, and we need to recover the left side, right, in case it has also, the left side has other children, right? So we will need to recover that part, just normal DFS on a tree essentially. And we do the same thing for the right node, and so node.right would be equal to 2 multiplied by node.val plus 2, right? And then we will need to cover again the same way. We need to recover node.right, okay? And then what should happen after that? So once we do root.val in our set here, we need to add this value, right? So dot values, we need to add root.val, so 0, just add 0, right? And then at the end, we don't need to return anything. But one thing is that here, while traversing, we want to add the values that we find, right? We don't want to redo it again, right? So all we need to do for that is just node.val, so that at each point this function is called, it will add the value. And so here it will add it when we call it for the left, and it will add it for the right. So for every node that is not like the none, it will add the value to the set. So that means we don't need this because it will be called with the root. And so root.val will add it here, right? And now our find already checks if it's in the values, and that's pretty much all we need to do. Yeah, so let's run this. And we can submit. Okay, so that passes. We can slightly change this just in a small way to make it like less code in a way. And so the way we can do that is, instead of setting the value, because the problem really doesn't care if we recover the tree, all it cares about is if there is a target in values. So we can just pass the node value and not really set them in the view, on the node itself, because all we care about is populating these values. So actually we don't set it, we can just pass it as a parameter, and so that would be val, and that would mean here it will get the val, and the initial value is 0, and after that we pass the value for the left node, which the child will consider its parent value, and we'll keep doing this. And so we don't need to set the nodes actually. So this one is like this. Here, depending on the interview, if the interviewer really asks us to really recover, then the first approach would have been right. Here, just because Leetcode doesn't check whether we really recovered the trees, so it doesn't matter, right? Okay, so that's pretty much it. Let's run this. There is one thing wrong. This is val, not node.val, because node.val we didn't change it. It would be -1. So we start out with 0. We need to add val. Sorry about all these typos. So we need to add val, pass node left, to pass the new value. That's good. Okay. Okay, so that passes. Let's submit. Okay, so that passes. Yeah, so that's it for this problem. Please leave a like on the video and subscribe. Thanks for watching, and see you next time. Bye.